In this video, we're going to take a look at the unit circle. On the left, there's a circle provided here, and what we're going to do is we're going to make it have a radius of 1. If a circle has a radius of 1, that's what we identify as the unit circle, because if you think of the word unit meaning 1, our radius has a value of 1. Now, on any given point along a circle, we can always classify it as just some arbitrary value, x, y. And how do we know that that's xy? Well, based on the origin, we know that in order to get to that other point, what we would have to do is move left or right along the x-axis, x units, and then we'd have to go up another number of units, y units. And so what you can see here is that you're going x to the right and y up, and that's what gives us the ordered pair x comma y. Now in doing so, you also see that you have formed a right triangle. And on this right triangle, you can also classify an angle measure inside there. Let's call that angle theta. Okay. Now a couple other things to note here. Because we call this the unit circle, remember that every spot along the circle has a radius of 1. Meaning, if I were to extend the radius in any direction, right here, let's say, we have a radius of 1, and that means that this ordered pair would have the ordered pair 1, 0. If I were to extend it in all directions, I could see that this ordered pair at the very top of the y-axis would have the ordered pair 0, 1. And likewise, over here on the x-axis on the left side, we would have the ordered pair -1, 0. And over on the bottom of the y-axis, this would be the ordered pair 0, -1. Okay, so that's just understanding that with a radius of 1, any point along the circle, along the vertical or horizontal, will always be a maximum length of 1 there. Now, if I were to look at the actual trigonometric ratios given the angle measure, let's take a look back at our trig ratios. What I want to find are the trig ratios such as cosine of theta, okay? Cosine of theta, if you recall from the previous video, is the same thing as representing the ratio of adjacent over hypotenuse. And the adjacent side in this case would be a length of x, because we're just going some arbitrary value along the x of the triangle. And then it's going to be over the hypotenuse, and the hypotenuse for this unit circle will always be a length of 1. So you can see here that this trig ratio, simplified, actually just gives us the form of x being the same as cosine theta. Likewise, if we want to find sine of theta on our triangle here, well, we can see that sine is represented by opposite over hypotenuse. And opposite is the length of y over hypotenuse of a length of 1. So in this case, we can see that y is really the same as sine of theta. Okay, so there's another trig ratio that we have discovered. Now, if we put this all together, then what we notice is that at some point we said that we can classify any point along the circle as some arbitrary x, y value. Well, if the ordered pair is x, y, and x represents cosine theta, we could just use substitution and see that in ordered pair form with the angle measure, you can classify the ordered pair as cosine theta, sine theta. So cosine theta, sine theta is another way of representing the ordered pair xy, but using angle measures instead of lengths of along the unit circle. A very powerful technique that we'll use a lot more as we go on through the trig units. Now, in addition to cosine and sine, we could also find another trig ratio. If you recall, the other trig ratio was tangent. And if we want to find tangent of theta, remember that tangent represents opposite over adjacent. Opposite of the angle theta would be y, and adjacent of that angle theta would be x. So tangent of theta is the same as y over x. Well, we also actually found what x and y were equal to. So tangent of theta, using substitution again, is the same as y, which is the same as sine of theta, over x, which is the same as cosine of theta. So it turns out that tangent of theta is equal to sine theta over cosine theta. Another cool property that you'll use a lot throughout this unit. Let's take a look at the example provided on the right. If we want to find cosine of 0 degrees, then remember from a previous lesson that the way that you measure angles is start off with the initial ray In this case, the 0 degree mark starts here, and then from there you go counterclockwise and you work your way up. So maybe this might be like a 45-degree angle. Well, if we're at 0 degrees, that must mean that our angle measure doesn't stop anywhere. It just stays put, which means you're going to be at this point 1, 0. And so if you're trying to find the cosine of 0 degrees, recall how cosine in ordered pair form is the same as the x value in the ordered pair. So cosine of 0 is going to be a measurement of 1. So cosine of 0 equals 1. I'll let you do the rest.